This is for Year 12 Methods. It's VCAA 2016 Exam 2, question number 4, Part D onwards. So we have our hyperbolas changed, so the 2's been replaced with a k, where k is bigger than 1. In Part D it says show that if x1 is smaller than x2, so therefore x1 x2, and that's bigger than x2, implies that the y value of x1 is less than the y value of x2, where x goes from minus k to infinity and x2 goes from minus k to infinity because my domain is minus k to infinity. Okay, so if g of x1, the y value, is less than that, then my gradient has to be positive. So show that this implies that, well, if x increases, y increases only if the gradient is positive. So let's take the derivative of this. So I've done that over here on the calculator. I've entered it, taken the derivative, and I got g dash of x to equal k squared minus 1 over x plus k squared. Well, the denominator is positive because it goes from minus k to infinity, therefore x is always minus k or bigger, and it can't equal minus k, so that's always going to be greater than 0 and positive. And k is bigger than 1, therefore this is always going to be bigger than 1, therefore the top is positive. Positive divided by positive is a positive, therefore the gradient is always positive. Therefore if x2 is bigger than x1, therefore that implies that this is the case. Let x be a position on, let x be the point of intersection on the graphs between these two. So I've done that. I've put this equal to negative x and solved it for x, and I get two answers. I get minus k minus the square root, and that's no good because my domain is from minus k to positive infinity. Therefore I can't have minus k minus anything because it'll be outside my domain. So x equals minus k plus the square root of k squared minus 1. So the coordinates will be minus k plus the square root of k squared minus 1. And if I put this into minus x, the y value will be k minus the square root of k squared minus 1, because y will be negative x. The next part, find the value of k if the x coordinate is this. So I'd want this to equal negative a half. So if I take minus k equals negative 0.5 and solve for k. K equals 5 on 4. Okay, let z be negative 1, negative 1. Let y be 1, 1, so it's on the line y equals x. And let the vertices of the triangle be, let s. Okay, so the distance from along there, going from 1, 1 to negative 1, negative 1, is a distance of 2 root 2. So the area of the triangle is going to be a half base times the height. So if I consider this to be the base, it's going to be a half 2 root 2. And the height's going to be this distance here. And I've already calculated that that would be to here if k was equal to 5 on 4, but it's these coordinates if k wasn't 5 on 4, because it would be different values. It'd be any value going up to here depending on what k is. So that distance is actually going to be equal to the square root of that squared plus that squared, giving you the distance from here to here. I'll just put it on the calculator. And I'm told S of k is the square of the triangle. So S of k is going to equal 4 k minus the square root of k squared minus 1 all squared. So that's S of k. The graph of G and the line of y equals x encloses the region in the plane. The region shaded in the diagram below. So I know that this intersection point should be 1 and 1 and negative 1 and 1, but I'll just confirm that. By making that equal x, and I'm going to solve that, but I might take it into a new line down the bottom. And when I solve for x, I get negative 1 and 1. So always, no matter what k is, and of course k takes my curve along the line y equals minus x. So find a rule for the area. So the area is going to be the integral from negative 1 to 1 of top curve, which is kx plus 1 over x plus k minus the bottom of x dx. So if I get that into a new line and I make that minus, I select it, interactive calculation, integral, definite integral from negative 1 to 1. Okay, that gives me that expression, simplify the answer. I know that this will be positive because k is bigger than 1, and that will be positive. So I'm going to put that into a new line, and I'm going to cut that, get rid of the modular sign, and then paste. And I'll do the same here. I'll cut that, get rid of the modular sign, and paste. And any more, grab that, get rid of the modular sign, and paste. And then simplify the answer. These can be combined to give you equals k squared log base e of k minus 1 on top of k plus 1 plus log base e of k plus 1 k minus 1 plus 2k. These can actually be combined to say that I have, this can be flipped upside down, this can be flipped upside down and say I've got minus k squared log base e of k plus 1 on top of k minus 1 plus log base e of k plus 1 on k minus 1 plus 2k. And I can combine these two together and get 1 plus k, 1 minus k squared log base e of k plus 1 on top of k minus 1 plus 2k is going to be, and show that this is going to be the value of a of k. Okay, when the value of k gets really small, then my area is going to be approaching 0, and when k brings the area right out to here, then I've got this point here, an asymptote and an asymptote. This region will approach the area of that rectangle, and the area of that rectangle is going to be, sorry, that goes up to 1 and 1. Area of the rectangle is going to be 2, therefore a of k is going to be bigger than 0, but a of k is going to be less than 2, because the maximum area that this rectangle can be is 2.